on the last exciting episode of Worthless Unity Challenge.
Look at that. I have kind of done it. Well, hello, Dancing Fetus here, and we're picking right back up where we left off. And where we left off is we had the framework of a very basic platformer that would have been, I'm sure, extremely popular, setting the world on fire if I would have only developed this in like 1984. 2016, it's really not that impressive, but let's keep going for the sake of this video series. So this is what makes the magic happen. We got a player sprite. The player sprite has a player script. The player script controls player movement, and it also has my gravity method, which is pulling the player down. And then we have our world objects, which are these platforms here. The world objects have the world script, and what this script does, it says, hey, if the player falls within the width of your x-axis, send the player the maximum y position it can fall before it lands on you. The result is this. So let's look at the script real quick of what's going on. So here's my player script. It's got a bunch of variables there that we really won't go into. It's got some movement controls through here, and this is my gravity method. And then we have the world scripts here, and it's just saying, okay, is the player over you? If the player is over you, send the player your Y position. So all those, when they get sent to the player, get stored into a list of floats. Because this takes into account the fact that if the player is over multiple platforms, that it lands on the one closest to it, so the tallest one. So let's show you an example of that real quick. So say right now, only one Y position is being sent to the player. But if the player was over two platforms like this, and let's tier them so I can fall onto the other one. The player stops here, and both platforms still work, but both platforms are now sending their maximum Y position to that float array in my script, and then I'm picking the highest position to tell the player where to stop falling. This works beautifully, I might add, on things that are flat. However, when we go over to things that are not flat, oh, look at that. That is not what we want. Alright, here's the game plan to solve this problem. The issue is the player is keeping at this Y position, even though it should be, instead of doing that, it should be keeping with the slope. And the reason this is happening is just because how Unity renders sprites. Like basically, as far as Unity is concerned, this entire sprite is a box like this. So when I get the sprite's position right here, and then I check for its extents, it goes all the way up here, because the sprite render is a box as far as Unity is concerned. Unity doesn't even know it's at an angle. It's just rendering a sprite, and it's saying this is its maximum Y height, this is its minimum Y height, and the min and max width. So the player has nothing to do but to stop on the box, because that's how Unity calculates it. Well, what we want is we want the player to go down the slope like so. So we have to give the player a different Y position based on where the player is at on the slope of the angle of the sprite. So we're going to accomplish that with trig. So to get the player, who's right here, to land on this part of the platform, we're going to have to communicate to the player a new Y position. This is going to be pretty easy to do if we treat this entire thing as a right triangle. So if we say that the player position is the far left of our triangle, and then the far right point of the triangle is the furthest x position, positive x axis position, and then since it's a triangle, we'll go ahead and draw this. Boom. So we got a side, which the A side is going to be the new Y position we communicate with the player. Then we have a B side, and then we have a C side. And since this is a right triangle, this is 90 degrees. And we also know this angle too, because we're the ones that actually rotated it. So if we look at our Unity thing right here, we see that we've rotated this platform 15 degrees on the z-axis. So that means this angle right here is 15 degrees, and that would mean this angle right here is 75 degrees. And the reason that is all angles for a triangle have to add up to 180. So 75 plus 15 is 90, 90 plus 90 is 180. Boom, we got our angles. We also have a side. The C side is the distance between the player position, and in this case the far right side of the sprite render, and that's because the right side is tilted down. If the left side was tilted down, it would be the distance between the player position and the far left side of the sprite renderer. And here be the fruits of our labor. Look at that. Isn't that awesome? Yeah, there's some overlap because I'm not actually rotating the player, but the fact that it's just following down the sprite like that is, in my opinion, pretty awesome. Let's show you some of the magic behind the scenes of what's going on. Okay, there's been quite a few changes. Some of the bigger ones is I've added some variables here like C angle, A angle, and A side. A side is what we're going to be communicating to the player as our Y position on any sprite that's been rotated. And I've added some logic here in my update function, so now I'm checking to see if the player is over the sprite, which we've always been doing, but I'm also checking to see if the sprite is rotated. If the sprite is rotated, I'm saying that the world Y position, which is what I send the player, is like, hey, this is the furthest you can fall, is the lowest Y, which the lowest Y I'm setting as this platform's Y position minus its Y extent, because in Unity the platform position is this circle right here, and then if you subtract the extents it would get me this number right here. So that's the lowest point of this sprite render box. And then I'm saying you take the lowest Y and then you add this method I wrote called calc angle. What calc angle does, it runs a trig function that calculates the A side based on the C side of the triangle, and then the C angle and the A angle, and then it returns the A side. And here is the end result. So player here on this non-rotated sprite looking all happy and stuff, and then it lands on this rotated sprite, and oh, look at this. Now it's following the slope. And that is because instead of getting the maximum sprite rendering extent of this platform, it is now basing its Y position on the A side of our right triangle, which involves the player position down to the lowest point. That's the A side. The C side we're using is the difference between the player position and in this case, the far bottom right corner of the sprite renderer. And that's pretty much how the cake is made. It's constantly calculating the distance between the player, and since it's angled down on the right side, the distance between the player and the far right side of the sprite renderer. Based on that, it gets the A side of our right triangle, and based on that A side, we add that to the lowest Y position of the sprite renderer, and the player just follows the slope. Bada bing, bada boom. Well, this hasn't been the easiest video I've ever made. I was talking about a lot of stuff that might be really confusing, and I didn't really do a deep dive in all the mechanical stuff that I'm doing in the background. So if you have any questions, feel free to drop me a line. I'm willing to explain anything, and if you want to just look at the code and kind of just like sort out exactly what I'm doing, feel free to check it out over at my GitHub. Links on the screen. Thanks for watching.